Before we dive into the world of various lighting options in the Unreal Engine, I would like to swiftly overview what are three different types of light mobilities. First, let's select any source of light in this level. To do so, we can search for lights in the outliner. Simply type light and select any source you like. I'll select the directional light. Okay, now let's discuss what mobility means and how it works. The first option is static. This mobility is reserved for light actors that are not intended to move or update in any way during gameplay. Static lights play a role in generating pre-calculated light maps via light mass. They provide illumination for the scene and produce lighting information for actors designated as static or stationary. However, for movable actors, their lighting is derived from data stored in either the indirect lighting cache or volumetric light maps. To put it in simpler words, use static lights for static objects like buildings. This is the least GPU-hungry option as light data is baked in so-called light maps of the 3D assets. Note that while it requires less resources from your GPU, it actually outputs best lighting results. The drawback is that the asset with a static mobility setting can't move and its intensity, color, and other properties can't be changed during gameplay. Note that since static light is baked in the light map texture, it needs to be rebuilt anytime you change its location in the editor. To build lighting, expand the Build tab in the menu bar. Then click on Build Lighting Only. Sometimes this process can take a while. If that's your case, pause the lecture and resume watching once building of light is finished. This stationary mobility is reserved for actors that technically can move during gameplay, but they don't. During gameplay, these lights have the ability to undergo changes, such as adjusting their color or intensity, or even being switched off entirely. Stationary lights play a role in pre-calculated light maps via light mass, yet they also have the capability to cast dynamic shadows for objects that can move. However, they do come with an extra expense and face restrictions on the number of lights that can impact a single object simultaneously. For instance, a single object can be influenced by a maximum 4 stationary lights at any given moment. In other words, color, intensity, and some other properties can be changed during the runtime, but it can't move in space. Another drawback is that you can have only several stationary lights in one given location. It requires more resources than static light, but is far less demanding than movable light. Use stationary lights where properties like color and intensity are important. For instance, I would use stationary lights for wall torches and campfires. Stationary lights also need to be pre-built. Finally, we have this movable light mobility option. This mobility option is designed for light actors that you want to tweak on the fly during gameplay. They can be added, removed, edited, and shifted in space as needed during runtime. These lights exclusively cast dynamic shadows and offer the flexibility to adjust their color, intensity, and other properties while the game is running. However, it's important to be cautious when using lights with this mobility setting because they come with a higher shadowing cost. On the bright side, non-shadowing movable lights are quite economical to compute. Even compared to lights set to static, the movable lights that don't cast shadows carry a lower cost since they don't require saving lighting data to disk. You can always turn off shadows that are cast by selected light by unchecking this cast shadow property in the details panel. Now, all shadows that were cast by the selected directional light have vanished. I don't know about you, but really don't like how the world looks right now. Anyway, it is solely your choice to remove the shadows to lower computational costs or to have them. Note that if you use appropriate mobility settings for every light and asset, your players will have amazing lighting and performance at the same time. When we start building our own games within the framework of this course, I will make sure to demonstrate how I use light mobility settings. I think now you know everything that is important about the mobility of lights in Unreal Engine. If you have any questions, ask away in the QA section. Thanks for watching, and I'll see you in the next lecture.